So in this lesson, we're going to start talking a little bit about proofs. It's going to be kind of the building blocks for where we're going with proofs. So by the end of class, we're going to be able to form logical arguments. So we're going to talk more about logic, how to string different statements together. It's going to help you in this basic idea here is going to help you with all the future stuff we do with proofs. And just having a better understanding of how to be logical, make a better argument in anything that you're discussing. And then when you can correctly write a true statement about a geometric idea, you know you got it. So first, let's talk about logic. Logic is decision making. Science that helps you make decisions based on facts or circumstances pertaining to an event. So there's three ways that you can make decisions. Intuitive, inductive, and deductive. Intuitive is your intuition, like your gut feeling. Inductive is when you look for a pattern and you kind of assume that pattern is going to continue. And then deductive is taking a more general statement and you're going to make it more specific. Deductive is like when a lawyer is trying to make a case. They start with a more general statement and they're trying to pinpoint it more specific on the if they're a prosecutor, on the person they're trying to convict. So you're narrowing it down, bringing it more specific. We'll talk more specific about those here. So your intuition, like I said before, it's like a gut feeling or a hunch. And inductive inductive, you are looking for a pattern and then you use the pattern to continue. You make a guess and then test it. A conjecture is kind of like a guess. So now we use inductive reasoning to look for a pattern. And then we're going to make a guess about the next numbers and we'll test it out. So looking at these numbers, 1, 1, 2, 3, 5, 8, 1 plus 1. If you add 1 plus 1, you get 2. If you add the next two numbers, 1 plus 2, you get 3. And if you add 2 plus 3, you get 5, which is the next number. 3 plus 5 is 8. That's where the 8 comes from. Then 5 plus 8 is 13. 8 plus 13 is 21. The next number must be 21. 13 plus 21 is 34. And then 34 and 21. 21 plus 34 is 55. So our third number there would be 55. Adding up the previous two numbers gets you the next number. Sometimes there might be more than one answer when you look for an inductive pattern, though. So a deductive reasoning, deductive logic, makes conclusions from things that you previously knew, like theorems, postulates, and definitions. And deductive reasoning takes general premise and it's going to deduce it. It's going to bring it down to a more specific conclusion. If you make a conclusion, it must be contained in the premise. Every what needs a valid reason. Another way of thinking about that. You have to have the first part of it fulfilled. The premise has to be fulfilled in order to use it further than that. So typically, this can be done by having conditional statements, an if-then statement. If A, then B. Commercials do a lot of if-then statements. They don't actually use the words if and then all the time, but you can kind of break it down. Like, if you use this shampoo, your hair will be shiny and smooth. Or if you switch to Geico, then you save a bunch of money. So commercials marketing uses if-then statements all the time. They say, if you buy our product, then something good's going to happen, something you're going to want. So one of my favorite children's stories is all of these actually, but here's if you give a mouse a cookie, if you give a moose a muffin, that's another one. I'm actually more familiar with moose and muffin, but here's if you give a mouse a cookie. I think this is the first one in the series, but it gives a whole bunch of if-then statements. So listen for it a little bit. See if this will work. So, with all that, those are all if-then statements that can be strung together. The conclusion of one statement became the premise of the next. Had a new conclusion, a new premise, a new conclusion, new premise, and they can string them all together. That's the idea behind deductive reasoning. So, going off that, if you give a mouse a cookie, if you string all of those if-then statements together, so if you give a mouse a cookie, he's going to want some milk. If you give him milk, he's going to get a milk mustache. If he gets a milk mustache, he's going to want to look in the mirror. And you can string all those together. So that means that if you give a mouse a cookie, you can conclude, if you jump all the way to the end of that story, he's going to want another cookie. You can get rid of all that stuff in the middle, and if the premise is true, you give a mouse a cookie, he's basically just going to want another cookie. So that's what deductive reasoning leads to. So there's another thing called the converse. And that's just where you flip the conditional statement. If B, then A. And if a conditional and the converse are both true, you can write that statement in if and only if form. That's called a biconditional. If and only if biconditional. So here's a statement. If a rectangle has side lengths of 4 inches by 26 inches, then its area is 24 inches squared. That is true. Because area is length times width. So 4 times 6 is 24. That's true. Now we're going to write the converse. Converse means switch the order. So you take the part that comes after the then, and that becomes the first part, the if. So if a rectangle has an area of 24 square inches, then the beginning part. If a rectangle has an area of 24 square inches, then it has side lengths of 4 inches by 6 inches. So it's kind of a silly way that I remember Converse, but maybe it'll work. Converse is a type of shoes. Most people are aware of Converse shoes. The only thing that you can really do wrong with shoes is put them on the wrong feet. Right? So the only thing you can really do wrong with a pair of shoes is switch them. So Converse has to do with switching them. It's the only thing you can do wrong with shoes, switch them. So when you switch the statements, that's the converse statement. So with this converse statement, is that true or false? If it has an area of 24, do the side lengths have to be 4 and 6? That's not true. So if it was true, we write it as a biconditional statement, and if and only if, but it's not true. There's a counterexample The side lengths could also be 8 inches by 3 inches, or maybe even 12 by 2. Either one, that would be a counter example. So we can use deductive reasoning to string conclusion, or to draw a conclusion by stringing some arguments together. If two angles form a linear pair, then the two angles are supplementary. Then we're told that angle BOT and TOM are a linear pair. So that means angle BOT and angle TOM are also a linear pair. You can draw a conclusion based off of a true premise.